All right, welcome everybody to day 4. We're so excited to have you. We have had a great week so far, and we are excited to have a great last day as well. Today we're going to have a response to a reverse pitch, some breakout sessions, and also a fireside chat. So looking forward to some great information to come. I do want to remind you that all of the session recordings will be posted under the session recordings button. All of Monday, Tuesday, and Wednesdays are now posted, so feel free to take a look back at the week whenever you have time. We will post today's sessions, including the breakout sessions as well. Okay, so we are going to get started first with a response to a reverse pitch. Let's make sure that all of our speakers are unmuted and ready to go. I think we're going to get started here. I'm going to pass it over first to Mustafa from Blue Wave AI. Mustafa, over to you.
Thank you, Hannah. I appreciate it. Let me start by thanking EPRI for providing us this platform to discuss and exchange ideas. My name is Mustafa Farrokh Abadi, and I'm the Vice President of Technology at Blue Wave AI. So starting my presentation, let's start just discussing a little bit of who we are. Blue Wave AI is a company founded in 2017 with the headquarters in Ottawa, Ontario, Canada. We started with a 3-person team. We are now more than 20-person, including expertise from all range of technical spectrum, from software development to power systems engineering to machine learning, including 5 PhDs in our applied science team. We have so far within the past 3 years raised $5 million between our pre-seed and seed round, including $2.4 million from Sustainable Development Technology Canada government grant. Our prototype product was and it still is in operation. It's what we claim is the first AI-enabled dispatch in a Canadian utility for the city of Summerside in Summerside Electric. We have a very active IP portfolio. We have 1 USPTO granted and 8 active non-provisional applications. Our product and projects are present on 3 continents, including long-term software as a service contracts in place. And we have received multiple international and national awards that all don't go through the details in appreciation of time. Our business is to enable the transition to smart grid by providing a holistic end-to-end solution that includes predictive analytics. We have developed and implemented state-of-the-art predictive analytics applications for smart grids currently in operation by providing data-driven and adaptive optimizers, which are responsive to the fast-changing operation in renewable penetrated smart grids, and by providing a distributed energy IoT platform that is specifically designed to respond to the needs of the high dimensionality operation of modern grids. Our product architecture, basically, if you think of the utility scale power plants, the centralized large scale power plants, as well as renewable energy farms on one side of the story, and then the distribution and the medium voltage, low voltage level part of the grid on another side of the story. Obviously, these two are connected through the transmission grid, and then we are sitting in the cloud. We have 2 modules, what we call Blue Wave AI Center module that sits in the cloud. It hosts our central database. It interfaces with external data sources such as renewable service providers. It also interfaces with other customer end user customer applications, and then it communicates with what we call Blue Wave AI edges. So it could be multiple modules, either physically sitting on the customer's premise or logically hosted in the cloud, and it interfaces with the customer's control and monitoring assets. So basically, the Blue Wave AI Edge modules could also communicate with the energy trading system in applications that are necessary to consider for the market mechanism. This is just a quick snippet of how we would set up and communicate with devices from the customer. So we have developed our own tailored libraries that would enable fast interfacing with the customer's devices and agnostic to the protocols and agnostic to the device technology. Just also going through briefly through our that framework library that I just mentioned. We have worked to provide in-house libraries that supplies common capabilities for interacting with the entire operation of the customer as well as our internal architecture. This is a framework that is developed in Python, and it includes basically a holistic connection between our edge modules and center modules, which are basically part of our platform, as well as our model and studies, which is part of our product and software. In terms of how we conduct business with our customers, typically speaking, our project rollout phases begins with what we call assessment phase. Within this assessment phase, we take through the customer data, through the customer system. We build verified simulations using the simulation approaches that are again built in-house to come up with an estimate of what would be the value proposition of our intelligent predictive analytics and predictive optimizers for the customer operation. After that, we could basically take it into two different paths. We could go into a further detailed what-if analysis to understand what would be the best path forward for the customer, or we could directly delve into product development, integration, activation, and deployment. So that's typically the project roadmap that we'll take and have taken so far with all of our customers. We have a strategical focus on EV fleet simulation, predictive analytics, and optimization tools and products. We have multiple in-house demos and simulators that would enable the electric vehicle fleet operators to gain a deeper insight into their operation ahead of the massive electrification of public transit and private taxi driving systems, as well as any other operation that might have a fleet of electric vehicles that are going through the transition from internal combustion engine vehicles to electric vehicles. Now arriving at the response to the pitches by utilities, basically just briefing through this, not taking too much time. Our core activities include the smart grid related prediction, optimization, and control applications, as well as any application that pertains to decarbonization, demand response, and active controllable agents in the medium voltage, low voltage level of the system. We also have worked on asset management and digital twin kind of applications, and cybersecurity data management sessions are just essentially a feature of our product that we complies us with cybersecurity protocols. Okay, let me move forward. Perfect. So just an example of our EV-related projects, we are working with Hydro Ottawa, which is the electric utility in our own backyard, on a project which we called EV Everywhere. This is about working with Hydro Ottawa to take them through the large penetration of electric vehicles that is currently happening in the city of Ottawa, identifying the vulnerable parts of the system and proposing mitigation plans and devising demand response programs that would help the utility to go through the electrification. In terms of how it will look like, again, I'll don't go through the details, but what we have gathered and is gathering a large volume of data from the utilities SCADA system, as well as metering infrastructure, AMI from the consumers. And then based on that, we are developing a monitoring, detection, and controlling products for the electric vehicles in the system. This is another example of our intelligent energy management system developed for the University of Ottawa. This is essentially, you can think of it as a grid-tied microgrid that has a wide range of assets on premise, including solar panels, including energy storage systems, including building energy management systems. And we have developed a complete package, including the communication infrastructure as well as the control and optimization package, to essentially help the campus to make use of the demand response program that is provided by the utility, as well as efficiently managing the energy needs of the campus. So just going through snippets of what we have obtained, for example, in that project, we were able to essentially benchmark against the typical integer linear programming methods of what we implemented using our data-driven optimizers. We were able to actually increase the profit margin using the energy arbitrage by almost double of what would have been achieved by typical industry standard mixed integer linear programming techniques, by keeping the battery lifetimes unchanged. So it's not like we are depleting the battery more often to make use of that energy arbitrage. It's just we use the resources more intelligently, and by providing the optimizers with more accurate prediction of what's going on in terms of the price, in terms of the renewable generation, and so on and so forth. This is an example of the actual signals in the system of how we help the campus by peak shaving programs, obtaining essentially a 10% reduction in the campus peak by using the energy storage system as well as the building energy management systems. Another example that I'll just go through a little bit more in detail, and I'll end my presentation by actually going through a live dashboard of our product, is the optimal energy scheduling system that we developed for the city of Summerside. This is a relatively small, medium-sized city with a peak load of 28 megawatt, but quite an attractive electrical grid, because they have 12 megawatt of on-site wind generator coming from 4 3 megawatt turbines, quite a considerable penetration of renewable generation. They have on-site thermal, distributed thermal storage systems. They have on-site diesel gen sets, and then in between of all this mix of generators and controllable assets, they schedule their energy in hourly intervals from the upper grid transmission system operator, in this case, the New Brunswick system. And the problem that they are dealing with in particular in this system is that there are basically the supplied cost of electricity for the system ends up being a function of how accurate that schedule ahead of time is. What is the real-time price of importing and exporting energy to compensate for the inaccuracy of the energy scheduled ahead of time? And how much is the price of scheduling that energy ahead of time? So we basically ingest all of this degree of freedoms. We have developed a load prediction system, wind prediction system, price prediction system, and we have developed two types of optimizers, data-driven optimizers, a optimal energy scheduling system, which let the operator know about the demand that needs to be scheduled ahead of time, as well as using the distributed thermal storage system. This is around 450 electric water heater units that would further help to compensate for the real-time fluctuations in the system and inaccuracy in the energy schedule. Just going through the problem framework, I think I'm not going to go through the details of this, but it's essentially what you can think of as a two-stage problem. On the first stage, there is a power schedule, which is scheduled by our optimal energy scheduling system, as well as a power of generated by renewables that are basically our input into the grid. And then the output are the consumptions from regular loads and consumption from controllable loads, which is thermal electric storage units. And the idea is in between controlling the input of the first stage, which is P scheduled, it's P with the index of SCH, and controlling the controllable loads, which is PCH, which are our thermal storages throughout the system, we minimize a particular loss on the longer term, which is the difference between all of this scheduled power, generated power, and consumptions in the grid to reduce the supplied cost of energy for the system. So what I'm gonna do, I'm just gonna share my screen and go through a live dashboard of what how the operation looks like in the city of Summerside. So as you see, this is basically this is a real-time dashboard of our operation in the past 15 days. You could toggle between, or you can use a custom time range or any time range that you desire. This product has been in operation for the utility for the past 2 years, by the way. And this is just last 15 days, not a particularly selected time window. Just going through some elements of what you see on the dashboard. On the bottom left corner, you would see the actual wind supply in the past 15 days from the 12 megawatt wind farm. This is actually a particularly an interesting window because there was outages in the wind turbines due to the wind gust. And as you see, we are dealing with quite a fluctuating wind generation paradigm that sometimes reaches up to the 12 megawatts of nominal wind generation capacity. Now, the blue color here is what we forecast would be generated by the wind turbines from the utility. So that's one element of our product. In the middle, you would see our load prediction provided by the city. As you see, you can recognize the very strong daily cyclical pattern of the electrical demand. Currently at this season, because there is no need for electric heaters or air conditioning system, the load is relatively low. It fluctuates somewhere between a value of 10 megawatt all the way to a peak of close to, actually, if I turn on my tooltips, close to probably we are looking at 18 megawatt of peak during the past 15 days. And we have developed also a load prediction system. So the blue color, which you will probably struggle a little bit to see because it's of its high accuracy, is basically what we predicted the city load demand would be. So we ingest these two predictions alongside the price prediction. It's not shown here because the price prediction elements are actually a month ahead price prediction elements. You don't know the actuals of the price until the end of the month, so you don't see that on our dashboard. And at the end of the day, we end up recommending what would be the required optimal energy schedule from the upper grid. That is the black color. Here is what the city actually needed, the actual need of the city post fact, and then the blue is what we recommended ahead of time, which, as you see, they are also end up being pretty close due to the accuracy of our predictors. On the right side of the dashboard is just the analytics. You could see the energy import from the grid in the past 15 days. You could see the wind supply and again the city load, and then there's almost, we phased out completely the diesel generation of this customer. And again, some analytics about the mix of the generation energy, as well as what's happening with the weather service at the customer. So end to end, again, this product has been in operation for the past 2 years and has been on path to reduce the operational penalties of the utility by more than 50% in the past two years. So just sharing my screen. That brings an end to my presentation. I understand there's a QA session at the end, so I'll skip these question slides. Again, thanks everyone for your attendance. I appreciate every opportunity to discuss all these ideas with all of you. Back to you, Hannah. Thank you.
Thank you so much, Mustafa. That was great. All right, just a reminder for the audience that we do have Q&A available right underneath the video screen. Feel free to post any questions there and we will grab those at the very end. All right, over to Martin from INTERTEK. Go right ahead.
Thank you, Hannah. Okay. Hello, everyone. Thank you for being here today. First of all, I want to thank EPRI for giving me this opportunity. I think the format is a great idea to learn about the needs of the EPRI members and how vendors we can address these needs. My name is Martin Gascon. I did a PhD in nuclear physics. That was 10 years ago. Then I transitioned into data science, and I've been working for INTERTEK for the past 5 years. For those of you that doesn't know, INTERTEK is a large company, 50,000 employees. They have 1,000 laboratories. They're in 100 countries. And the group I am working with is the INTERTEK AIM, which is Asset Integrity Management. We've been working with power plant for the past 40 years. And when I entered into INTERTEK, I found this rich data set that we have in INTERTEK AIM, and I thought it was a great opportunity for me. Today, I'm gonna talk about INGRID. This is one of our products that I developed to benchmark power plants. Let me go to the next slide. Yeah, in this table, I try to address some of the solutions that we have in our group. These are about asset management, digital twin solutions. Also, some of the solutions are in regard with optimization, optimization and management session. Here, let me talk about the agenda. I'm going to do an introduction to INGRID, then I'm going to show a little bit of the INGRID dashboard, and then the ongoing improvements for INGRID, and finally the anomaly detection. So this is INGRID. INGRID is a public database that we created pulling data from different sources. You can go to ingrid.intertek.com. You don't need to sign. INGRID basically helps clients to understand their cycling plant operations, wear and tear cost, financial expense, and operating risk. It also helps to understand the impact of flexible operation on power plant cost. INGRID, as we will see, has dynamic tables, interactive plots, and improve the user experience and data visualization. So INGRID was specifically developed for power plant owners and operators who want to gain valuable insights into their generating assets, their performance, their efficiency, their reliability. INGRID allowed customers to gain a strategic advantage through the understanding of their relative position in the market. So let me show you next. This is the public profile that we have for INGRID. You can go and see all these power plants that you can see in the map. They have a profile. You have the annual generation, some basic information that we pull from different sources. Now let me go and show how INGRID works. And this is a paid subscription for some customers. This is the operational benchmark, and it works like in the following scheme. So first on the left, we have our unit, the unit fuel, age, prime mover, capacity. And we dynamically select a list of peers with the same fuel, prime mover, and similar megawatts and age using near neighbors. This is a machine learning method that you can, in a k-dimensional matrix, choose the neighbors dynamically. And this is important. I say it's important because when we are adding data to the system, so we are choosing these peers all the time. Every time you enter into your profile, you are choosing your neighbors. So whenever we are adding more information about the other plants, then the comparison is finer, no? It's more precise. Then we use INGRID cycling to calculate all the cycling variables. And finally, we use INGRID-ANALYTICS to check your historical cycles to see where you rank in this peer group. We go to the next one. Here, I want to talk about a little bit about cycling, because every time a conventional steam power plant is cycled, this means you have low ramping, on-off service, feed water heaters, pump, boilers, everything in the system suffers a rapid, large thermal and pressure strain, which cause long-term structural damage, and ultimately leading to more metal fracture, more outages, and more downtime. And this scheme below, we can see that the colder the start, the higher is the damage for the power plant. So this was one of the first work that I did after creating INGRID. So we collected the hourly generation for all the plants in the US, and this is more than 5,000 units. And then we were able to generate this type of plots, and we can see the duck curve in the top. So that's the fossil fuel. We did this work in 2016, but now you can see below the impact of the solar contribution in California and North Carolina. So this quantifies the cycling that will be required in the fossil fleet if the current solar contribution keeps growing. The fossil fleet was ramping up 1 terawatt hour in 3 hours in 2015. So yeah, let me go to the next. So, and this is what we see in our clients. So here we have the consequence of cycling. So this plot on the left shows the heat rate versus megawatts on days with the start in blue compared with the working at full load in red. So as we can see, the lower the heat rate is occurring on days with full load. The higher the heat rate, the lower the efficiency, and that's why in this plot on the right, we can see that the same unit, and this is for one of our customers, they show us a change in average heat rate from 2011 to 2017 that led to a 3% efficiency loss in only 6 years. And this is not only related to aging, but also for related to cycling. Now let me go to the INGRID dashboard. So this is the dashboard that a customer can see. So whenever you enter, you have in the top your fleet statistics, then you have your assets, and then you have your map, and then you have different options. You can click for cycling cost, operation, reliability, and financials. So this is the cycling. If we click in cycling, we can see on the top the cycling statistics. We can see the cost per transient, per call star, warm star, hot star, low follow, and then we can see below the plots. So if we click in here inside, we can see how much money do we spend for each particular unit. We click inside this block in every block, and we can see the split cost. So how this cost is split in cold, warm, and hot. If we go to the next one, here we can see the operational profile. In the top, you can see your unit statistics, then your peers. In this case, we have compared a natural gas unit with 783 megawatts from 1971 compared to another 15 units. And below, if we click below, we can see more values. So the annual values, the peer comparison, and this is important, your ranking. Where are you ranking in these 15 units? Below we can see the annual values. We can play with the slider over time. Then you can see more things, the cycling, the number of starts, and you can see the summary plots in which you can plot many variables on the same plot, and you can see how you compare your unit in red with your peers in blue, and they are normalized by 100%. The next one is the reliability profile, and here you can see the availability factor, plan average factor, force average factors, and the comparison over time. And it's the same idea. This has more information about the top systems with failures, the top failure mechanisms, and we can compare because we have a rich data set in our suite aware with data from 800 units. We can see also the top 25 outage events, and we can sort this plot in different colors because you can sort by occurrence per year, by megawatts per unit outage, per unit or per outage. Here we can see availability factors over time, force average factors over time. Okay, and this is the financial profile, it's the same idea. So we have more than 4,700 units in INGRID. This is the map you can see. You can see this is a public map. Now, what can we do in this for me? So we can keep up-to-date cycling operations. We can see the impact of flexible operations. We can highlight system with multiple failures. We can understand the relative position in the market. What are the INGRD improvements? So this is the current database plan, and we have many public databases. We're incorporating more, and then in red, those are the ones we're incorporating. And here is what we are adding. We are adding the INGRID predictive. So we have the INGRID database and the INGRID cycling and INGRID analytics. Now we have INGRID predictive, and now let me show you some of it. So this is going towards the digital solution. So here we have a physical asset and then the digital twin. Digital twin has different parts of information. Oh, sorry, I come back. We have INGRID is operational data, fleet aggregated data. I don't know why it's moving. Maintenance history, which is our suite aware. I am talking about INGRID only. Somebody's passing my slides. So what do we bring to the table? So we bring we bring subject matter experts and access to data for the past 40 years. Okay, let's go to the next one. Here we have neural networks. Sorry. Somebody's passing my slides. I don't know what's happening. Here, okay. This is one of the This is one of the work that we've been doing, and this was for EPRI, and this was in 2018. Here we predicted using neural networks one type of failure, which is called DMW failure. And this you can see in the top where we tested 56 different power plants, and we predicted this type of failure. And then we can predict the actual age of the failure. In this case, we've been using machine learning for corrosion fatigue failures, and we've been predicting using different models. In this case, random forest was giving me the different failures. We published this paper last year, and then we can see in the random forest we can see the importance of these features. So we can see that cluster were the most important ones. Okay. Now we have multiple time series. We use multiple time series using pressures and temperatures. We can predict how these temperatures and pressures are going to move. We have different examples. In this case, we've been, sorry, I don't know what's happening. We've been using machine learning to predict remaining useful life. And you can see the analytics. Okay, I'm going to skip to the next one. INGRID anomaly detection in 10 easy steps. Here I'm going to show only 4 steps. And this is an example of the thing that we can do. In this case, we can run, this is one of the steps in running the model. Here we can see the model in 3D, and we can actually see the anomalies if we zoom in. And this is plotting multiple variables. Yes. Okay. Okay. Now we can, next slide. We can plot the outliers by just clicking a button. Yeah, next. So here we can see that there is a drop in megawatts. So this is data coming directly from the Pi server. So we can see the anomalies when there is a drop in megawatts or a drop in some of the systems. We can also see Here is the compressor discharge pressures, and then we can see the ramp rates. So just by adding all this information, we can see the ramp rates and see when the ramp rates are high. Yeah. Next one. Now we can also plot, select any two variables. Let's say megawatts and belt mount inlet pressure. And next one, we can plot these two variables in 2D, and we can see the anomalies for these two variables. But we can also plot this in 3D, so we can select three variables. In this case, megawatts. Let me choose compressor discharge and inlet pressure. So when we plot this in 3D, we can search in a different way. We can search in 3 dimensions, and we can see if there are regions in which we see all outliers. Yeah, in the next one. So basically what we can do in anomaly detection is is find correlation between variables that didn't know existed before. We can do forensics on past data without having to define a threshold for each variable. We can plot ramp rates with a click of a button, so we don't have to do anything. And we can visualize outlier for 3D in 3D. And we have 11 anomaly detection models and 32 machine learning models for this anomaly detection. Yeah, next one. I mean, one main thing that these comparisons are very expensive, but they are really cheap per unit base. The different benchmarks. And we've been featured in Power Magazine recently. You can find this article here. Yeah, that's all what I have. I'm back to you, Hannah.
Great, thank you so much, Martin. That was great. All right, we have our last presenter up, Dr. Kendrick Carroll. Dr. Carroll, over to you.
Somebody give me a nod if they can hear me. Hannah, can you hear me? Good. Okay, so I got a nod. All right, perfect. Awesome. Well, thank you, EPRI, and all the attendees today for giving us the opportunity here at BSI to present our capabilities. So we titled this project here is called SIDES, SIDS, and what it stands for is Secure Intelligent Data Exchange. And so what we're going to do is we're going to introduce you to BSI as a whole. That's going to be the agenda. So we'll go over overview of BSI. We'll also talk about key industry challenges, specifically to AI. We'll do a quick insight based on some of our experiences working in the utility industry. We'll also talk about how we will help, who are we doing it for, and how can we collaborate. And as previous presenters already mentioned, we're all actually going to do a Q&A session at the end. So if you have any questions, feel free to drop them in the chat below. All right. So who are, this is the reverse pitch I'll go over. But who are we? Who is BSI? BSI is the leading innovative firm here in Charlotte, North Carolina, as our base headquarters. Our core expertise focus on innovative technologies. That's all we focus on. Innovative technology that consists of artificial intelligence, blockchain, extended reality, as well as quantum computing. That is the core of our business. That's the only thing that we focus on is creating innovative technologies. And in addition to that, we do have some staffing and consulting kind of services. But our core focus of our organization is really tying it to innovation. And so just recently, BSI was named as 2021 Charlotte Business Enterprise of the Year along with several other accolades that has just been presented. So if you see here, you'll also see the American Business Award, Stevie Award, from our innovation and creativity that we performed throughout the years, especially through COVID. That was another previous award that was granted to us, along with the International Business of the Year by Intercom. So as you'll also see some of our certifications, we are a minority-owned firm, as well as a service-disabled veteran-owned business. And so some of our areas that we really focus with associations, the AR Association, as well as American Cancer Society, just helping fight different cases of cancer using innovation. But let's get to the actual core, why we're here. So when we think about the utility industry and we look at things that's going around, a lot of us are very familiar with what just happened maybe 2 weeks ago when it happened with the pipeline crash and that cyber attack, and how it really transformed or impacted our economy and our customers. So some of the challenges that I heard from various different participants or just clients or utility companies is asset management, right? And we think about asset management, I think none of us are really new to the, hey, SIP is a critical part of that. Whenever we do, we got to make sure SIP stays a part of it. Being able to use image recognition for asset management. Also understanding what is the health, what is our asset health, right? So asset performance, as well as wanting to identify how can we start predicting the health and predicting outages or overusage, right? In addition to that, looking at the renewable energy, I think every utility company right now is going into, if they already started exploring renewable, is becoming a larger footprint. 2 days ago mentioned that they're looking to get changing their pie diagram from a small section to almost 90% of their footprint is going to be in renewable space, right? So we understand it's growing. So we're going into renewable energy, but how do we really sustain and how do we maintain using emerging technologies, given what our limited technology can do right now based on how the utility industry has been structured? Also heard some efficient in training with lower costs. Incorporating, NLP. I think that's something that we all, whenever we think about innovation, NLP is something that's automatically something that's going to be applied. And then once again, cybersecurity, get into cybersecurity. But one of the biggest ones that I noticed, and EPRI, I know you all have an effort to do this as well, is getting into that data sharing orchestration, right, between multiple utilities. Because when you think about AI, it's not so much just about using your own data set. You want to be able to help the system to learn and train it by using a rich data set, which not necessarily only focus from within your company. You want to be able to expand out. That's how you're able to train the model to even predict even more with higher accuracy. So then you see some edge computing. We won't get too far into the details on edge computing directly, but we will introduce it and how it can be leveraged. All right. So what is the quick insight? So when we think about AI, I always like to make sure we level set on what are we talking about when we talk about AI. AI it has become a huge buzzword, but a lot of times when people talk about AI, they don't necessarily know the difference between the various levels of AI. So when you think about ANI, AGI, and ASI, and I'm going to start from the bottom and go up, right? So ASI, this is where everybody kind of pulls their hair out, start kind of going wild and get kind of scary when you think about artificial superintelligence, when you think about machines just having emotions just like humans, being able to do different things, and when you hear about the apocalypse, things of that sort. That's not where we're at. So our focus is really on the top two. When we think about AGI as well as ANI, which is what we're hearing from the utility industry and different industries around, is how can we use ANI, AGI, levels of artificial intelligence that's based on data and computing powers to be able to help us perform and execute our tasks more efficiently. All right. So one of the key things, as you look at the bottom diagram down here, if you can see my cursor, one of the notes that I always tell our clients is understand that one technology cannot solve everything, right? AI is very powerful. AI is wonderful as a technology, but AI by itself will still have its limitations. So one of the things that we as an organization has been known for is really connecting the dots and creating ecosystems that are utilizing these different forms of emerging technologies to be able to allow the companies and our clients to be able to get to where they're looking for, right? So one of the things we say is AI is great, but we also AI want to be tied to different other technologies. In the case here, you'll see 3 different technologies here, and you'll see why we're talking through that and how we've done it with the Department of Energy. Okay. So how do we help? So we start with asset management. So this here is a very high-level diagram. I wanted to make sure it's digestible and comprehensive for the clients. And then if anyone wants to do a further deep dive into it, we can definitely do it. But this here is what we're calling the size, right? So this is the Secure Intelligent Data Exchange. And what is this doing? This here is creating a centralized repository in a sense, but it's not moving all of your data to one database. No, what it's doing is, I think I heard one of the presenters, not presenters on this call, but one of the utility presenters mentioned, hey, why can't we create some form of data commons? Why can't we create something where within a utility space, we can really collaborate and work together to solve this mutual issue that we're having across the industry? Well, in our words, feel no more, because this is exactly what we do. We have created a platform, or a data commons platform, to allow this to take place. So what you're seeing here is in the center is a data commons platform. So a client like EPRI or someone that's centralized will be able to have data that's coming in, but it doesn't have to create a whole new database. So it may be a TVA or Duke Energy or a Dominion Energy that all want to be able to collaborate together. And so what we're do is create this platform to allow these systems to connect to each other, but that's done with credential base, right? And so the credential base is not something that an AI is able to do. So this is where you introduce other technologies like your blockchain technologies to be able to provide that level of security inside of it. And so what happens is you have this centralized place where anyone that's participating from the utility industry can come here and be able to pull data that they're authorized to be able to see. And so what happens with that data, it does various things. It can go into the AI itself, which is the AI model where it's going to start doing the analysis, start doing the predictability, where it creates and start doing and does all the learning. Well, prior to getting that data over to the AI, it starts at the beginning, where you want to be able to utilize things like, when we think about image recognition, utilizing technologies like drones, right? Using drones to go out and conduct assessments of your assets, understand where the health is at, and taking that data and bringing that back to, once again, that centralized location, which is your database, but is allowing it to be shared with other utilities. And you can provide limitations on what's been done and what's been shared out. But then you also say, okay, well, we still got these other assets that we may not be able to utilize for the drone, or the drone to be able to perform the health assessment on. No problem. You take that data that's formed on whatever kind of system that you have in place as far as gathering the health of these different assets, which I've heard everybody has a rich data set. It's more so about how to use that rich data set. So over here, if you take your rich data set and make it available into this area, what you do at that point is allow the AI system that we incorporate using machine learning, neural network, and deep learning, and allow it to be able to train and grow and increase the accuracy of, hey, is there going to be an outage? Hey, how are we performing? Should we go up or down? Should we shut a plant down because because of energy and the supply and demand, right? It allows you to be able to control your assets more efficiently. So that's for any of the renewable assets. If you look on here, you can see all your different forms of assets in there in the portfolio. Okay. Next slide. So what else are we looking at? So when we talk about training, so one of the things that we heard as well is that, hey, we have an issue with training. And I think it was Southern Company that actually mentioned it, that they started using some level, and I know Duke Energy is doing it as well, started utilizing virtual reality, extended reality technologies. So how does this connect to AI? Well, actually utilizing extended reality by itself is one thing, but also getting it incorporated when tied into your databases where the AI piece comes into play, allowing you to be able to predict, hey, this is something that's going on, understanding the training is going on, understanding the risk level that's associated with that employee or that worker before they actually go out to a site. Thus, you want to be able to reduce your safety infractions that's going on. So as you see here, you'll see some of the things that has been created, things that we've also rolled out using virtual reality, augmented reality, and mixed reality to be able to maximize resources, being able to utilize the talent that the utility industry or client has that may be retiring off. Right, a lot of talent in the utility industry is going to be retiring off here in the next 5 to 10 years. So you want to be able to take that knowledge that's has been acquired over the years and deposit it into the younger generations that's coming up. So utilizing things like mixed reality and virtual reality, augmented reality that's tied to AI is another solution that utility industries or companies are really looking to do. So that's one of the other areas of expertise. And then finally, all right, so BSI Trust. So this is a proprietary platform of software that has been rolled out confidentially. I can't disclose all of the agencies that are participating. I can't say that the Department of Energy is using it. And so what this does is exactly similar to what I mentioned at the beginning, is tying all of the technologies together, right? The situation is having each of these technologies can work by themselves, but really bring it together is really where the sweet spot comes in at, and has been proven to be very effective, which is something I'm hearing within the utility industry is looking to do as well. So this technology is proven, is out, is rolling out. Some of our largest high security federal agencies are utilizing these different platforms right now as we speak. Okay. So as we go AI to de-identify critical information to clients and to customers, things that's done automatically. We'll also provide credentialing for users to be able to access certain devices, especially when it comes to the cyber attacks that's going on. As we all know, that the one thing that hackers have been looking to do is to take down the grid, right? But having something that with immutable security is something that's really going to protect the grid even more. That's going to prevent hackers from really getting inside of it. And once again, if we want to get more detail into it, I definitely will share my contact information here at the end for us to be able to have a deeper dive conversation. And then, of course, like I mentioned, virtual reality is connected from the training. So who do we do it for? So these are just some of the select clients that we are currently working with. Some of the clients can be on. We want to add some more onto it. But as you can see, one that's more applicable here in this conversation is the one on the bottom right. The bottom right here, the Department of Energy. The Department of Energy are using our platforms, our technologies, and allowing us to come in to help them identify how do they innovate. The one thing about us that we believe that one solution doesn't solve all problems. So the approach that we take is we come in first and start understanding not only your problem, but also where you want to go. And from there, then we start educating on what technologies are available and how can they actually be utilized systematically to be able to solve your problem, meet a problem, but also scale with you in the future. The one thing we don't want to do is create what we call the new legacy system. That is the thing we really stand hard on. Is not create a new legacy system, create using technologies that's going to expire in the next couple of years or 5 years, thus causing the client to spend even more money. That we want to be a cost savings providers as well as an efficiency provider. So helping you operate more efficiently, but also giving you an opportunity to save costs so you can invest in other areas. So with all that being said, we'll move over to questions, but I know we got Q&A at the end, so I'll just go over to the final slide, which you can see some of our contact information here. Once again, with BSI Solutions, based here, headquarters inside of Charlotte, but we are working internationally. We've done works in Australia, we've done works in Switzerland. We're actually all over the U.S. here, and we'll continue to move forward. We got a couple of roles that's getting ready to open up here in China in the next, probably in the next couple of months. So with all that being said, Hannah, I will turn it back over to you for any questions or comments from the audience. Thank you.
Great, thank you so much, Dr. Carroll. That was great. We do have time for a few questions. We've got about 6 or 7 minutes left. I'm going to try and hand each of you one question. So we'll start here with Mustafa. Can you comment on any utilities where Blue Wave has implemented smart grid solutions or others you've mentioned in other countries?
Sure, yeah, of course. So as I mentioned, we are currently operating on 3 continents. These in Canada, these include 2 utilities. We are working with Hydro Ottawa as well as Somerset Electric, one in Ontario, one in Prince Edward Island and Eastern Province. We are working with Tata Power Mumbai. That's the utility of Mumbai back in India. We are also working with a major utility on the East Coast of the United States, which I cannot disclose the name, but that's on a virtual power plant project that we recently kicked off as we move forward in that. So it's a signed project and we're working with that, but we are still tied by confidentiality. We are also working with Dubai Electric and Water Utility on a proof of concept project, as well as an independent power producer in UK, Scotland, which we are working with. On top of this, we are actively having ongoing projects with major taxi driving companies as well as EV fleet operating entities. These include a taxi driving company in New York that, again, I cannot disclose the name. Dubai Taxi, we are having an ongoing MOU that we are working on a project with, as well as a wide range of fleet operators and airports that we're working with. Just mentioning a couple of names, this include Kingston Transit in Ontario, Alaska Airline, and then the fleet operating enterprise in California.
Awesome, that's great. Thank you so much for that. All right, Martine, we're going to go over to you. What are the biggest barriers INTERTEK has had with generating their database?
I mean, combining different databases, public databases, is not easy because the data is messy. I mean, when the power plants report this data, there is a lot of noise that we have to clean. That was one of the main. I mean, that's also happens. This also happens in the power plant. So the sensors are loose. There are spikes. There are many filters that we have to apply in order to get some clean data. Otherwise, we get the result is the same as the input, right?
Great, thank you so much. Okay, Dr. Carroll, over to you. Can you speak more about how you're tying AI to VR?
Make sure you can hear me. There we go. So when we think about AR and VR, one of the cases where we use is being able to desensitize data that's coming into the VR environment, especially when it comes to image recognition data. When we think about it, in some of the cases, there's information that's on that data set that cannot be disclosed, but when you bring it inside and render it inside of a VR environment, we need to be able to make sure it's desensitized or de-identified. So that's one method that we're actually utilizing. In addition to that is utilizing AI simulators when it comes to training that's taking place, being able to utilize those simulators to be able to help the user, the trainee, go through the proper protocols that are required to reduce safety infractions to make sure that it's muscle memory for the user. So those are some of the cases that where we're tying AI and VR together, as well as using, even when it comes to mixed reality, is allowing that information to come from the database, but your database where you are housing all your information, but also housing your inventory as well, because there is a heavy supply and demand when you think about the lineman that's going out installing the pole or things of that sort. There's still a supply and demand that has to take place as well. So tying all that back together is another area where we're utilizing AI.
Great answer. All right, guys, we are at time. It is 10 o'clock Eastern, so we are going to move to a break. We will be on break until 10:30. When we come back, we're going to be in breakout sessions. We're going to have 3 breakout sessions from 10:30 to 11:30. The first one is going to be smart grids, the second one is going to be digital twins, and the third one will be cybersecurity and data management. So when you come back, just click on the links in the agenda. There'll be a slide up explaining exactly how to click it. You can feel free to move in between each breakout if you'd like. The password is the same for each of the breakouts. It's just reverse pitch. So we will see you guys back here at 10:30 for the breakout sessions, and then we will end the day with a fireside chat at 12 o'clock Eastern. Thank you so much. See you back at 10:30.